likely to go.
Oh, crap. I don't know what I just did.
Oh,
No, password.
you're fine.
Oh,
Because
here.
it was already an auto, like it,
No internet.
no internet. Okay.
So we could just try all 4 of them, I guess.
These are hot. I would have to go back into the, they didn't give me access anymore, but I could, if I could get to it, all I have to do is go to this number and turn it on. I actually learned how to do that because we were so often not having enough work.
Still no.
What else we have that's,
There's those, but none of them are marked either. So.
well,
Um,
for my area, because I know we're limited.
I don't think so.
Okay, so this is 3227. Let me see if I can get into that room.
Yep, still don't think so.
Well, except they went to
I was 16 when I finally got one because I had to pay for it myself. It was the pink Raider book.
Hey Danny, this is Nicole in the science department. I know one of the actual classrooms, not laboratory classrooms, but the lecture classrooms. And we're trying to get a port that's hot. There are all kinds of connections, but
I like
nothing
those.
is hot. Who has access to the room for making sure the Ethernets are connected?
You're one of those people that are gonna do it.
Oh, okay. Okay, sounds good. Let me give you the room number. Is it 322?
or no, you're right. 22.
He steals my thunder picture. Other than that, he's like, I don't care.
All right, thank you, Danny. Right. She's on the first floor. She'll have that.
Oh, how did these fit in?
So. Great question. I think they were alligator clipped. Yes. And then alligator clipped, and there were 3 for a reason, maybe, let's see. Then there were the 2 in the beaker. I don't remember how this was. There's 2 in the beaker. And then alligator clipped. And then this was.
Before I get my degree, I'm gonna get my.
Oh, man, maybe this was something.
You know what? I won't even be mad.
Because that
Fine.
goes through there, and this with a negative end.
Do we know which one?
This is black one.
Oh, yeah.
Those are the 2 alligator clips.
So you just typed in something and it formatted an entire paper.
Yeah. I only learned about it from South Park.
So then it goes into the.
It goes, yeah, it'll go into,
So the negative one is there.
And it just compiles them. There are also now applications that like, if you like did that for.
It don't matter if that eyeball one distilled water.
You want one distilled and one with 1 molar.
Like an entire thing of that.
Yeah, I didn't have any made up.
Yeah, I'm
Okay.
gonna just roughly dilute it.
Okay.
You could do the,
I did too. Yeah.
so then this goes to here.
Yeah. We need a bigger one.
Maybe. Oh, here we go, sorry. And then this goes to the copper.
I was wondering why we have a third one. There's a reason why we have a third one.
What do you mean?
There was also one that they did.
Is it called, Declan wrote up that we needed 3 alligator clips. When you're trying to adjust something. Oh, yeah, okay, okay, we got it. I see for these two, okay, that makes sense. I just wanted to be sure.
So
And then a
I just
beaker.
need- Yeah, the beaker, and then obviously water pro to monitor the current.
Yep, okay, and this just is if you want to use the mouse.
Oh,
Okay, so Logger Pro, which is in here somewhere, right?
No, it's,
This, right?
no, that's your,
well, that's
it's
just
the computer system.
Oh, I see.
Yeah,
So
we
is
have,
it veneer or logger? I was mixing up.
it will tell you.
It
Oh,
says
and you want
logger.
channel 1.
I think
Yeah, I put it in channel one.
I think it's on the back page of the front page. I think I saw Vernier, but I'm not sure what it was.
Logger Pro are newer, so it's not the graph, the
Okay, so-
analytical graph.
So what am I doing with beakers?
We're filling it up and diluting,
Yeah, so one we need to
but
put
you need gloves.
just roughly.
So should I just bring like a thing of distilled water?
Yeah, I don't see one in here, so.
Yeah.
Can I just take a couple bottles off of a table?
Or in my computer.
Sorry, I need a mouse.
Oh my God, it was crazy. I had 5 hours of sleep because I came in at 11 o'clock last night. We didn't even leave Portland till 5. Yeah, my girlfriend had a bunch of errands and I had to wait for that community service. And the community service place was in Vancouver, Washington, and it just happened to be 10 minutes from where we were staying. So I said, I'll get your ride and then I'll help her with her errands and just have a girl day. So it was really quick and improv, but are you going to talk to me on Monday? Because they were going to banks and lawyers and business stuff, so. It's like came in early this morning, set up my stuff, finally looked through it, and then I had to go run and get stuff by 2:11 because I was having me sprouted. And the respiration. So that's it. The 16 are looking, they're great. I didn't feel it great. Like I thought of everything except for, all I knew is on Friday when I left. Speakers who grabbed, but I don't know if he's a fit. Yes. I don't know if he knew I was sprouting. Maybe, maybe not, but he was saying. When I. Yeah, they were perfect. They were great. I'm so happy. I got all the food out last night. I was in here. Oh, that's because they came from the greenhouse. I sent them on Friday to the greenhouse to have the warm temperatures of Lucifer. And I said to shipping, receiving, and Michelle, be sure to have them back Monday. Because they don't arrive till noon.
Do you think this will be enough water?
Yeah, that should be plenty.
What you doing? Making a demonstration. I actually don't know.
I bet what the demonstration was, electrochemistry?
Electrolysis, is that what it's called?
You're trying to find Avogadro's number.
Oh, okay. Okay, so how much do
And
you
then
need?
I took a pack them up, sent them to Grant's Pass, and said, be sure to come back Monday, because I gotta be here by
I don't
Monday.
know.
So they came back, and then somebody put in, did you
What
put
was
in?
for that end of there? And roughly, so we could make sure.
Yeah.
is pure distilled,
Kind of.
and the other is,
And then the
Yeah,
beans
except-
I didn't exactly
Here, I could get it too, because I would put the sulfuric in there first, because I want it like 3/4 full, but half of that. Because it's supposed to be 3/4 full of 1 molar, but we have 2 molar, but then acid in the water.
yeah, gotcha.
Yeah.
So acid first, then add water, right?
Oh, acid into water, so water, acid into water.
Okay, so water and then acid.
Yes.
And you said you wanted,
Yeah, so I would take out some water is what I'm saying, like that's probably too much. Okay, this is at least reading. I think.
you want it basically to be diluted to half, right?
Yeah. All right, let's go ahead and get started. Sorry, we're a little late. So let's talk about your field trip, or labs, not labs, exams, and then we'll talk about the demo and all these things. Oops. And welcome in the chat. I see you. Oh, just send the sources. All right, so let's talk about the exam really quick. So I'll probably hand them back at the end of class. But overall, I was pretty pleased with them. But there were a couple, basically, if, at least like if you tried, I think most people did well, but some people, just left it blank. And I want to offer a chance to redo to try to get everybody kind of to the same level. And so I'm going to offer 50% back for redos for anything that you got wrong. And so that will probably help some people. So I'll offer that and probably want to do that ASAP. So I'll hand those back at the end of class or whenever we have some downtime. And then, so let's talk about the Oregon Caves field trip. So that's this Thursday. And so if you can't come, it should be, let me go back. Try to put it in student mode. So it should be under lab week 6, and there's just a video available. It's from some guy that used to work there, but he kind of goes over the chemistry. And if you really don't want to do the video, that's fine if you just want to research the Oregon Caves and give me a paper instead, but the video at least gives you something to go off of. So there is that. But I hope y'all can join. Should be fun. So just note the drive, and so it says don't use the GPS, so follow these directions, because I guess the GPS takes you down like a dirt road that's not marked. And so it tells you their travel time, so 30 minutes from this milepost 12. So Dorothy said it might take 2 hours from Medford. I'm not sure. I haven't been there personally, so. Okay. Good to know. And so our tour starts at 11:30 officially. I'm telling people to get there, like aim for 11, just in case. And then make sure that you dress warm, so apparently it's cold. And then Michaela had brought it up earlier when we first talked about it, but you want to wear clothes that have not been in caves. So it mentions that because of that white nose bat syndrome. So, and no pets. Any questions?
So, in the folder in Blackboard, it says to read the background info and do the pre-lab, but there's nothing else in the folder. Is there, lab?
I have like some extra background stuff. I can post that. I just haven't yet. It's mainly from the video, but you could also ask the internet. But I'll post what I have when I get a chance. So.
Will you also post the alternate assignment for this last cycle?
No, this is it.
Oh, okay.
Yeah, like it's the video.
The answer?
No, it's the same questions as the lab.
I see.
Yeah, and then you write a page about the video then. or if you don't like the video, you can just write a research paper about the caves or cave formation. You know, you could compare like Oregon caves to something else, but so in case you don't like video watching, yeah.
It was a little dry.
Yeah, I watched it once.
Maybe it's a little hard to follow.
Yeah, I understand it's dry, so that's why I'm saying like you could just skip it and write a research paper instead, just about something with caves. But. All right, other questions? Hopefully we are. All right, so let's dive into electrochemistry then. And we'll see how far we get on this chapter. We may have to continue it on next week since we're not having class, obviously, with the field trip. And with that, with the quiz, I'm thinking maybe like a take-home quiz that I can email out or post on Blackboard. Would that work for people? Yeah, just so we don't miss our free quizzes. And so let's look at electrochemistry. And so first thing we can do is just kind of define a couple of basics. And so we have, this is just a diagram of Volta's apparatus for generating electrical current from a chemical reaction. And so looking at this, we have, so voltage is just equal to the pressure that pushes electrons through a conducting loop. And so you can kind of almost think about that as like your potential, so almost like a waterfall. And so voltage, if it's favorable, which we'll get to, you know, what is favorable, what is not favorable. But essentially, right, that's pushing those electrons around our loop. If you kind of recall back, remember that's kinetic energy, just those movement of electrons. And so in this formula here, we have U, which is electrical energy, so equal to our voltage times our charge. And so we could put this in other units. So we have a joule is equal to a volt times a coulomb, and then you have an ampere, which is equal to a coulomb per second. So you could figure out your total charge with this formula. All right, so we have our setup up front, and so we're going to kind of do this, but we're going to do something cool with it. So we're going to attempt to figure out Avogadro's number based off of these things. And so let's set up our kind of experiment of what we're doing today. Oops. So we have two, what am I doing? Sorry, off base. So we have two pieces of metal. So we have our zinc and our copper. So we're going to have to weigh them in a second. And so our zinc, and then we have here, this box is just a power supply, so that can supply our current, so that's going to force current to pass through. And so zinc is hooked up to the negative end, and then copper, if you look at this setup, I'll kind of show it. Let me switch cams. People online too. Oh, camera's a little out of whack. There we go. So now you can kind of see the setup if you're online. And so this is measuring the current. And so we'll start by kind of setting the current. So that's what I have the computer here. But once we have our current, we can run this for a certain amount of time, figure out how much total current was passed through, and then compare that to the mass difference. So we're going to have to mass these beforehand. Then we'll mass the copper after and see how much it gained. And then that will tell us how many electrons were gained or lost in that process. And then we can figure out Avogadro's number. So we'll walk through that. And so yeah, this is hooked up in the middle of our current. And so you can see, so copper's hooked up to the positive end. goes up over there. So copper, I'll just draw that positive. Then our little meter, so we can measure our current, and back to the box. All right. And so then we'll set up our data table, and we'll see how this goes. So we have our initial mass of copper. So we'll record that. Our final mass. And then our average current, so we'll read that from our current. Then we'll have time, so time in seconds, so we can get back the total amount. Oops. There we go, sorry. So then we can figure out the total charge that was put in coulombs. I think we're actually okay. Because the Logger Pro is reading. I don't know if this is live hot or not. But yeah, if you could check that out. But it might be okay if it's running.
It is not. It does not appear to be.
Well, it's just like Logger Pro's up.
Ah.
But yeah, I probably
It
doesn't have.
recognize anything being plugged in.
Ah, yeah, so that would be cool.
Give me 2 seconds. I will be right back.
And I think we should be losing mass, actually, because we should be forming copper 2+ ions once we add electrons to it. And so it should lose mass. All right. Let me run and grab some steel wool because I want to polish them, and then we'll mass them, we'll stick them in there, and then we'll see what happens if we can get this to work. All right, now we have some sandpaper. So I'm just going to, I'll switch back cams. So of course you notice the zinc sometimes gets the oxide. So I'm just polishing that. Zinc, so I'll hook that back up just to the black. And the copper doesn't look too bad, so I'll give it a little polish. All right, so now it's all shiny. And so I have my balance, so I'll go ahead and mass it. All right, I have 0.352 grams. So we'll put that, switch back. And hopefully our balance is sensitive enough. A little concerned.
Capital A stands for amperage, right?
Yeah. All right, I'll get back up. And so let's just go through our lab. So we clean the copper, we have our beaker. So now beaker with 1 molar sulfuric acid. So first, I'm just making sure the voltage isn't on too high or anything, so I haven't turned it on. Connected the zinc to the black, copper to the red, and don't have them touch. So now this is connected, that's connected, perfect. So power supply is off, blah, blah, blah. Place the electrodes. Only concern is they're not really upright. I don't, whoop! That was not what I wanted. Okay, I might have to get some stands for them.
Bless you.
I'm gonna try this flipping. Okay. Let me get some little stand to hold them. I don't know that we need it though,
Oh, no, okay.
because Logger Pro's up.
I mean, no lock with it. So I went to the server room and confirmed that one of these ports should be live.
Oh, okay. Yeah, that's what I was gonna do, but I don't have a key anymore since they put the keypad in there. I used to do that for the science labs. Not yet. We'll be starting interviews. I'm waiting for Declan. He's
Are you
gonna go
okay
through
now?
the process with me since he's new to that.
I
So
guess,
he's here Wednesday, Thursdays, and Fridays. So hopefully this week we'll start doing interviews and I'll reach out to you.
I'm sure about the Ethernet thing.
Yeah, it looks like it at least doesn't need it.
Yeah.
All right, I'm gonna do, hopefully do the demo. All right, so now we're set up, or at least hopefully we are. Does someone want to help me keep time? As it will? Okay. So we need to, of course, keep track of the seconds. If you could just timer that. And I'm going to just hit this power button.
I'm ready, you're ready.
And then first I'll have to adjust it. So I'll turn it on. And, okay. Are you timing?
Oh.
Cool. Perfect. All right, so looks like our current is 0.232. We'll round. It's holding pretty steady there. So that's our amp. 0.3 or 2.3, sorry. And then let me know when it's almost 3 minutes. So we want to let this go for 3 minutes. So 2, 3, 2. And so again, current, so this is coulombs per second. Yeah.
Roughly where did the 3-minute interval come from?
Oh, that's just the lab. To let it run long enough so hopefully we notice a difference in the mass that we can measure. And then we'll figure out basically how many electrons are passing through from our charge. And so we can talk about that. Keep an eye on the time for me, I appreciate it. And so we can talk about how we're going to calculate this. So we have that this is a coulomb per second. And then we'll also figure out, so the charge of one electron is 1.602 times 10 to the negative 19 coulombs. So we'll figure out first, based on our time, how many coulombs, aka electrons, pass through. Then we're looking at our process. So we're only looking at the copper here. And so right now, we're producing copper 2+ ions in solution. And so we should have a loss in mass. And so we'll get that mass difference and then do a proportion. So basically you'll have some sort of change in mass over some sort of electrons. And then we want to figure out, can we calculate Avogadro's number? So we'll do this for a mole of copper and see if we can get Avogadro's number. All right, first question.
Why do we need the 3-minute interval if we have the weight of an electron and the
30 seconds left.
Okay, 30 seconds left.
and the coulombs per second? If you have both of those, shouldn't you be able to just solve for it that way? Do we even need to check the?
But we have to have a time interval. So the 3 minutes is just our total, and then just tell me when to stop it. You have another question?
So where's your power source?
Power source, oh,
Is in the,
stop.
in the zinc?
No, it's in, so we supplied it ourselves. So this would be non-spontaneous. And I don't know, you can come up and look at it now, but the zinc was kind of bubbling. But yeah, we brought power to it this time. So then electrons were passing through, and so now it's off, because obviously if it kept going.
Oh, it's all in the same solution.
Yeah, so it's all, and you can, if you want to come up and see the setup, I encourage you to. So power supply, sulfuric acid, so we have movement of electrons, right? So we needed some sort of ions in solution. And then this is just hooked up in here to measure the current output from this power supply. So none of this was chemically spontaneous. We were forcing it essentially. All right, I probably should have grabbed a chem wipe. Let me grab a chem wipe so I can dry the copper. We'll see if there's a mass difference. If not, we could run it for longer. Hopefully we have a difference. All right, let's see what we get. I'll go back, whoops, to our data table. Hopefully this is accurate. So we have, I lost my other pen. So now it's reading 0.332. Now it's at 7. We'll go with 0.337. So 0.337 grams. And so now we can start doing some math here. So I'm just going to plug in these values.
15 difference.
So total amp was roughly 0.232. And then, so if we went for 3 minutes,
And 1 second.
so let's have that time in seconds. Take off my goggles for now. Sorry, I'm firing up my calculator. Should be like 181, right?
Mm-hmm.
So 181 seconds total. And so now let's calculate, again, this is just the definition of the ampere, is coulombs per second. So let's get total coulombs. So total coulombs is equal to our amps then, times our total seconds. So I got like 42 coulombs roughly. And so now we need to figure out how many electrons that is. So do our conversion. Want to get electrons. So 1 electron is equal to our coulombs here. -19. Oops, sorry. So ignore my second number, but about 2.62 electrons. That's electrons. But now we need to figure out, so how many atoms of copper were lost. And so if our reaction is copper going to copper 2+, so how many electrons are involved in that process?
Take away 2 electrons.
So losing 2, so plus 2 electrons. So then how many, if we said we pass this many electrons right through our copper, but it takes 2 electrons, how many atoms then of copper do we have?
1.
Yeah.
to 20.
I wish I hadn't done that. Sorry, I'm gonna redo the math, because I'm irritated at myself. So we get that, yeah, then divide by 2, so perfect. So 1.31 times 10 to the 20 atoms of copper then could be involved.
That's how many atoms were lost, or like how many atoms
Right,
went into solution?
yes. And so hopefully it matches with our mass difference, so we're getting there. And so let's see how many moles we get. So what was our, I think somebody had said 15. So 0.352 minus 0.337. So yeah, 0.015 grams lost. So in theory, this should match up. Let's see if it's true. So probably the easiest thing is we could set up a proportion. So 1 gram is equal to this many atoms. And so if we wanted to figure it out for 1 mole of copper,